Welcome to Section 2, Introduction to Fraud Detection. This is Lecture 4, What is Fraud Detection? So, by means of a definition, fraud detection is the process of detecting anomalous financial records from within a broader set of normal transactions. We assume that a financial services organization, if they're operating effectively, the majority of their transactions would and should be normal in the sense that they're not fraudulent. Although fraud does creep into many and most organizations in some way or form, and fraud detection is the act of actually attempting to detect those suspicious transactions from within the sea of normal transactions. The data is typically tabular in nature, meaning that it has rows and columns. So you can think of data within an Excel spreadsheet, for example, as being tabular data, assuming it has a rows and column structure to it. Although fraud detection does occur in other domains as well, you could take a text-based approach. There's a lot of work around graph techniques and graph neural networks, but the majority of the transactions are captured in a tabular sense. And it's very important for us to have access to historical instances of confirmed fraudulent behavior, as these end up acting as our target variable or our labels for our data. These are often tricky to get hold of, as they are generally generated by a third party, which could be a bank or another financial services provider. And the turnaround for these transactions, or rather these labeled transactions, can be quite timely. So it can take up to 60 days for some banks, I guess depending on where you are in the world, for them to actually confirm whether something was fraudulent or not. So you can imagine that if you've got a fraud detection process or model running and you want to evaluate the effectiveness of it in real time, it is difficult to figure out what the actual ground truth is, purely because it takes so long for you to get that confirmed record back from the bank. And because fraud is by definition less frequent than normal behavior within an ecosystem, naturally you're going to end up with far less confirmed fraud relative to normal or good behavior, therefore leading to what we call an imbalance between the fraudulent and non-fraudulent samples. That means that if you look at all of the non-fraudulent samples, you add them up, you look at all the fraudulent samples, add those up, the non-fraudulent or the normal transactions are going to outnumber the fraudulent transactions by an order of magnitude and more. Feature engineering is also crucial in fraud detection, and it typically involves conversations and interactions with domain experts, whether that's you as a data scientist or a fraud analyst or a fraud investigator, and taking those insights and that domain knowledge and transforming that into data points that can be used to detect suspicious behavior. Right? And these features that we use within models, they are typically aggregated at the customer level or at the transaction level, depending on the use case, and some approaches might even combine the two. So what we mean by aggregated at the customer level, we can look at the customer's transactional behavior over time, aggregate those things up, and say, for example, how many transactions had the customer made over their lifetime, or over the last 6 months, over the last 7 days, over the last 24 hours, that kind of thing. And then at the transaction level, there the data is aggregated at a different level. And a customer can have multiple transactions. So you might have multiple records for a single customer, which is fine. but in that case, you're trying to detect fraud at that transaction level. But you could even augment transaction level data with customer level data. So you can say, well, for each of these transactions, the corresponding customer who actually made that transaction, what was their spending habits over the last 30 days, 7 days, 24 hours, etc. Then network data is also important within fraud detection. So that's data that tells us how users within a system are connected to each other, if they are connected at all. And it's normally quite a strong indicator of fraudulent behavior. So if you've got customers within your ecosystem who are very closely linked via devices or IP addresses or credit cards, these kinds of things, typically that's not normal behavior. It might be normal maybe within a family context, maybe within an organization of sorts, if there's sharing of those kinds of resources. But by and large, from a single customer perspective, that's quite abnormal behavior. But looking at that data point alone wouldn't be enough to tell you whether something was suspicious or not. Rather, you would use that in conjunction with other information that is presented to you. And data sets for fraud detection are notoriously difficult to access due to various issues related to data privacy, companies not wanting to give their trade secrets away, or simply, enough of it hasn't been kind of published within the public domain. Luckily, there are some popular data sets that are available online, one of them being the ULB Machine Learning Group credit card fraud data set that has been published on Kaggle and that we will be using throughout this course.